on 15.7 and 15.8, Introduction to Cylindrical and Spherical Coordinates, 15.7 and 15.8. Introduction. We're going back and forth between rectangular coordinate system, spherical coordinate system, and spherical and cylindrical coordinate system. So on page 2, we have the following example. Example says, convert from cylindrical to rectangular coordinates. In this example, we have the following. We have find the rectangular coordinates. Find the rectangular coordinates of the following point. Of point P, which is given as r theta z equals to 2 and 3 pi over 4, and we have 5. There you go. So what are we doing? We are actually just converting our theta into x and y. Why is that? Because our z is just 5. So z is equal to 5. We don't have any problem with our z. So z is equal to 5. We know that x is equal to r cosine theta, y is equal to r sine theta. So our x is equal to r, which is 2, times cosine of 3 pi over 4, and y is equal to 2 times sine 3 pi over 4. Remember that cosine of 3 pi over 4 is going to be negative. So here you have 2 times negative square root of 2 divided by 2, which is equal to minus square root of 2. This is your x value. Your y value is going to be just 2 times square root of 2 divided by 2, which is square root of 2. So you can write x, comma y, comma z, which is equal to negative square root of 2, positive square root of 2, and z, which is equal to 5. A point in x, y, z space. Let's take a look at our point. Negative square root of 2. Next point. Positive square root of 2. And finally, your z is equal to 5. This is your point in x, y, z space. Next example, on page 2. So in this example, we have find cylindrical coordinates for the following point. So now we have rectangular coordinates. We want to find cylindrical coordinates of this point. The point given is x, comma y, comma z equals to negative 3 square root of 3 and minus 3 comma 5. Well, we have x, y, and z, and we're converting that into cylindrical coordinates. Remember that z stays the same, so your z is equal to 5. We know that r is equal to square root of x squared plus y squared, and also tangent of theta is y divided by x. The first one says here you have square root of If you square it, you get 9 times 3, 27, plus 9. So you have square root of 36 over 6. This is your R. How about your tangent theta? Tangent theta satisfies this relation that tangent of theta is equals to y over x, so you have negative 3 divided by negative 3 square root of 3, which is 1 over square root of 3. The options that you have for your theta, these options are actually pi over 6 or 7 pi over 6. 7 pi over 6. Which one is our final answer? Take a look at your x and y. Note that your x and y are both negative. X is negative and y is negative. It means that you're located in the third quadrant. In the third quadrant, theta is 7 pi over 6. So your point has first coordinate, which is r, 6. Second coordinate, 7 pi over 6. And the last coordinate is equal to z, which is 5. How about some conversion in spherical coordinates? You can recall that in spherical coordinates, we define it this way. We say that ax is equal to, here you have rho sine phi cosine theta, y is rho sine phi sine theta, and z is equal to rho cosine phi. Phi ranges between 0 to pi, and rho plus square root of x squared plus y squared plus z squared, or the distance from the point to the origin. This is rho, Greek letter rho. This is not p. Now remember that your theta is in between 0 to 2 pi. Okay, let's take a look at some examples. On page 4, we have the following. It says, hey, convert p with coordinates 3 and pi over 3 and pi over 4 into x, y, and z. So this is our goal. We're going to use the information that we derive from spherical coordinates. We know that x is equal to rho sine phi cosine theta, y is rho sine phi sine theta, and our z is rho cosine phi. So suppose you have your rho and theta and your phi in spherical coordinates. This is the order that we usually represent the point rho, theta in xy plane, and phi, the angle that point makes the positive side of z-axis. Very well, our rho is equal to 3, and I have sine of phi, sine of pi over 4, times cosine of pi over 3. So here you have, again, sine of pi over 4 times sine of pi over 3. And finally, you have cosine of pi over 4. So here we go. We have 3 square root of 2 divided by 2, and here you have cosine of pi over 3, which means a half. So you get 3 square root of 2 divided by 4. This is our x. How about our y? We get 3 square root of 2 divided by 2 times square root of 2, square root of 3 divided by 2. Well, here I get 3 square root of 6 divided by 4, and finally I have cosine of pi over 4, 3 times square root of 2 divided by 2. This is my c. So my point is now converted from rho theta, which is pi over 3, and phi, which is pi over 4, into x, y, z. So I have 3 square root of 2 divided by 4, and I have 3 square root of 6 divided by 4, and I have 3 square root of 2 divided by 2. Let us move on to the next example. Now suppose you have your x, y, and z. Convert x, y, z. X, y, z, which is given as 2, negative 2, square root of 3, and 3 into rho, theta, and phi. Very well, let us begin. First of all, we know that rho is defined as square root of x squared plus y squared plus z squared. X squared plus y squared plus z squared. So rho is equal to square root of, our x is 2, 4 plus 12 plus 9, which is equal to square root of 25, which is just 5. This is your rho. At the same time, you know that tangent of theta, y over x. So let us use the information that we learned before. Y is equal to negative 2 square root of 3 divided by x, which is 2. So you get negative 3 over 1, or just negative 3. What would be our theta? Okay, x is in the first quadrant, and y is down on the fourth quadrant. It means that your point is in the fourth quadrant. Very well. So on the fourth quadrant, what do we have? The information that we have for tangent theta equals to negative square root of 3 gives you 5 pi over 3. Since x and y are in the fourth quadrant. That's the reason. Now how about phi? Let us think about phi. We can use this piece of information here, z equals to rho cosine phi. So from z equals to rho cosine phi, we know that cosine phi is equal to z divided by rho. But what is z? Z is equal to 3. What is rho? Rho is equal to 5. 3/5. By using a calculator, phi is equal to inverse cosine of 3 over 5. Let's use a calculator to approximate this value. This value approximately is 0.93. 0.93 degrees. Very well, so you can write this point in spherical coordinate using rho, which is 5, theta, which you found as 5 pi over 3, and your phi, which is approximately 0.93